Hi there. Hope you have a fantastic day today. This lesson I'm going to teach you rates of change. Of course, there's a PDF file on the description below for you to download if you like. Otherwise, let's go straight into it. First one. A radio transmitter M is situated 6 kilometers from a straight road. The closest point on the road to the transmitter is S. So we know that M to S is 6 kilometers. It's given, okay, on the diagram as well. A car is traveling away from S along the road at a speed of 100 kilometers per hour. The distance from the car to S is X kilometers, and the car to M is R kilometers. So we know that the speed of the car, which is dx dt, okay, so it's 100 kilometers per hour. So we write per hour here. There you go. So the questions is asking for dr dt. So let me just make this smaller so I have space to write on. So to find dr dt, let me just write this down. So dr dt, and we know that dr dt is equal to, let me just write this out, and it's already given dx dt. So we can just write dx here using chain rule, okay? So dx. And we know that dx dt is 100 kilometers per hour. So I just write 100 times dr dx. So now we just need to find dr dx. So from Pythagoras theorem, so r is the longest side, the hypotenuse if you like. So r, so let me just write here, r squared will give me x squared plus 6 squared. But 6 squared is 36. So I just write 36. And this is square root to give me r. There you go. Now we want to differentiate r, okay, respect to x. So then to do this, I write in fractional form first. So half plus 36. Okay, write in fractional index. So power half. That's what that meant, okay? So now I differentiate this. So I'm going to go dr dx. And we know that dr dx, we're using chain rule. So power angle trick if you like, power angle trick. The power is a half. So we bring it front and then we minus 1. So a half minus 1 is a half, negative, okay? So that become a half first. I write this power, I just differentiate power first, okay? 36, a half minus 1 is negative a half. That's it. And then now we differentiate angle. So this is the angle. So differentiate x squared is 2x. So I just write 2x. And differentiate 36 is 0. So we just leave that. And then now I just simplify this. So a half cancel with this. Now with the power of negative half, I can bring it down so it becomes positive. So let me just write this down. So become x over, so we'll bring the negative half down, become positive index, okay? So that's become this. It's like this, okay? 36 power of a half. But then I'm going to write in third form, okay? So power half is square root. So let me just move this up a bit. So that will give me x over x squared plus 36 square root of that. So this is dr dx. There you go. So now we can find dr dt. So let me rewrite this. So we know that from earlier, so we know that dr dt is equal to 100 dr dx. So that will give me, okay, 100 dr dx is x over x squared plus 36 and square root of that. There you go. So now just simplify it. So just go, this is equal to 100 x squared plus 36. So therefore, dr dt is equal to this. please pause the video and try this one yourself. Hi, I'm back. How do you go? Let me go through it with you, okay, to see whether you got it right or not. But before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into this. So first of all, we know that 3 meters per second is dx dt equal 3 meters per second. So the question is asking for dl dx. And then we know that from Pythagoras theorem, L is the longer side. Okay, so I just write here. So we know L squared is equal to x squared plus 4t squared. But 4t squared, so 4 squared is 16, so 1600 if you like. So x squared plus 1600. And L is square root of that. There you go. So now we need to find, okay, dl dx. So dl dx, let me just write this in index form first. So x squared plus 16, 0, and then power of a half. That's what that meant. Then we differentiate this. So dl dx. So dl dx. So we differentiate this is just use power angle trick. So the power is a half, we'll bring it down, and minus 1s become negative a half, okay? So that will give me a half, and x squared plus 1600 power of negative a half, and that is power. And then we do differentiate the angle. So differentiate the angle is 2x. This is the angle. So 2x. Now these two I can cancel out. So this will give me equal to x, okay, and then the negative a half, I bring it down, become positive index. So that become x squared plus 1600 and power half. That means square root of that. So there you go. That is dl dx. But then we need to write in terms of cos theta. Now if you think about it, okay, so cos, we have adjacent and we have hypotenuse. So we know that cos of theta is equal to adjacent, which is x, over hypotenuse, which is L. But L from earlier, this is L. So which is equal to x over x squared plus the L is this. There you go. So therefore, we can say therefore dl dx is equal to cos of theta. There you go. I hope you got it correct. Now part 2. So we need to find dl dt. Okay. So let me write this down. dl dt. First of all, part 2. So dl dt. So we have dl here. And then we times, this is dt. And we already found dl dx. So therefore, I can just write dx, okay? dx. And dx. But then we know that dx dt is this. That is dx dt, which is 3 meters per second. So I just write this down. So that is, we know dl dx is cos theta as well. And we times dx dt, which is 3 meters per second. So times 3. So which is 3 cos theta. So therefore, okay, dl dt is 3 cos theta. There you go. Thank you so much for watching. I hope you got it correct. Thank you again. Bye.